Sine series using C program. We know that the Maclaurin series expansion of f of x is f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 and so on. So here we want to determine a series expansion of f of x is equal to sine x, and the f dash x is equal to the derivative of sine x is cos x, derivative of f dash x is minus sine x. Again here f of 0 is sine 0 is 0, f dash 0 is equal to 1, f double dash 0 is equal to 0 again. Now next, if we find the third derivative of f of x, then the third derivative of f of x is equal to the derivative of sine x is what? Minus cos x, and therefore third derivative at 0 is equal to minus 1. The fourth derivative of cos x is again sine x, and sine fourth derivative at 0 is 0, and again the fifth derivative of f of x is cos x, and fifth derivative at 0 is equal to 1. So you can see here this sequence, that is 0 1 0, then minus 1 0, 0 1 0 minus 1, again it is 0 1 0 minus 1. So if you put all these value in this formula, we get the f of x is equal to, what is the f of x here? F of x is equal to f of 0, which is 0, then x f dash 0, so f dash 0 is 1, so here plus x into 1 plus x square by 2 factorial into f double dash 0. You can see here f double dash 0 is equal to 0 again, f double dash 0 is 0, then plus x cube by 3 factorial f third derivative of f of x at 0, so which is minus 1, plus x4 by 4 factorial, and again fourth derivative at 0, which is 0, plus x raised to 5 divided by 5 factorial, and fifth derivative at 0, which is 1, and so on. So now if we simplify this, then the f of x is equal to, this term is 0, then it is x, again this is 0, because of this minus sign it is minus x cube by 3 factorial, then next term, again this term is 0, we multiply by 0 here, so 0, then next term is non-zero term is x5 by 5 factorial, the next term will be x raised to 7 divided by 7 factorial, and so on. So now we want to write the C program for sine series. So here the two important things, the number of terms, that is we use the variable n for number of terms of series, and next thing is x is again we enter x from user, again it is in radian, okay, it is in radian. So now again to the main important points to find a sine series expansion, you can see here it is power is what? X raised to 1, then x raised to power of x is x raised to 1, x cube, x raised to 5, x raised to 7. So the power is what? 2 raised to I minus 1 for I is equal to 1 to dot dot I is from 1 to 1 and 1 to 3 up to so on. Next the in the denominator it is what? Again 2i minus 1 factorial. So now first we are going to determine one by one. First we are going to determine this series x cube, x raised to 7, x raised to 5, x raised to 7. Then we are going to determine separate, we are going to call the separate function for factorial, and so on. So first we are going to write a code for series x cube, x raised to 5, and so on. So now include stdio.h include new.h. The next void main next integer, we require two variables, say I, we require integer I, then n for loop. The next float say we are x, and then for product we are going to use p. Next printf enter the value of x, enter the value of x, enter value of, or enter x, just write out enter x. Then next scanf, since it is an floating point, so real number %f and x. Next how many terms of the series, so again printf we are going to use n for number of term of the series, number of terms of series expansion. Now next here say scanf %d, since it is an integer, %d and n. Next for I is equal to 1, I less than or equal to, we require n terms of the series, so I less than, we use this this loop for number of terms of the series, I less than or equal to n, I plus plus. Now next we want to, again we require one more loop to find a product, so here say int I, we require one more loop, so here we declare one more variable j. So for since it is odd term, that is 1, then 3, then next will be 5, so for j equal to 1, j less than or equal to 2i minus 1, 2i minus 1, j plus plus. Now next p is equal to, say p is equal to p into x, so every time we want to multiply, now we want to take here p is 1, okay, p is equal to 1, so every time it takes p is what, 1, and then we multiply here 2i minus 1 times, we multiply x pi minus 1 times, that is x cube, x raised to 5, and so on. Now if you print this p, printf say %f, you will get the series, we are going to use new line here, %f and p. See here we complete the for I loop first, this I loop, then then next we want to print this series, okay. So now if you compile this, if we run here, enter x, so how many we want to enter x, and number of terms say 4, so you can see here it is x 2 raised to 1, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 7. So here we get what we get here, we obtain here this x we obtain like this. X, we obtain here the terms like x, then x cube, x raised to 5, x raised to 7. But since you can observe here, the series of sine series is x minus x cube plus x raised to 5 minus x raised to 7. So it contain alternate positive or negative sign. Alternate positive or negative sign. So next we want to think about the positive and negative sign. So we are going to take one more variable here for sine. Sine is equal to 1, and we multiply here p is equal to sine. We multiply sine by the product term, and then we are going to change the sign here. Sine is equal to minus 1 times sine. So every first time it is positive, next time it is again. Okay, so we want to multiply instead of here we are going to multiply here sine into p. Sine into p. Now you can see here 0. If we run one more times, okay, 2 and number of terms say 4, then you can see here first term is positive. Okay, we are going to write here first, clear the previous output. Clear the previous output. Now if you run, and if you enter here x is equal to 2 and number of terms say 4, you can see here alternate positive negative sign. That is, we are going to find here 2 raised to 1, then 2 raised to 3, 2 raised to 5 and 2 raised to 7. First term is positive, next one more time, if we run one more time, say 2 and number of terms say 6. You can see here first term is positive, then negative, positive, negative, positive, negative. Now we want to divide this term by factorial. So now we are going to declare one function for factorial, and then we are going to call this function. So integer factorial real int say yum. Okay, and then we are going to call this factorial here. Okay, you can check whether it is factorial is printing or not by just here, if you call say printf, say if we print here factorial, want to print factorial j. So printf %d factorial real 2i 2 star I minus 1. Okay, now we want to write the first function for factorial. Say so integer factorial okay, integer yum. Then next declare variable integer say I, and say one more variable fact. Fact, we are going to return this fact. So fact is equal to 1 for I is equal to yum, I greater than 0 and I plus I minus fact is equal to fact is equal to fact star I. Okay, and then want to return fact. Okay, so here we first take I equal to m, then we multiply fact by m, then next I minus 1, so it is m minus 1, then m minus 2. So what is the factorial? It is m minus 1, m minus 2 up to 1. So return fact. Now if we close the, if we want to just print factorial, so if we compile this, okay, and if we run, say x is 2 and say 4, okay, new line, want to print this factorial on new line. What we want here, we want the 1 factorial, then 3 factorial, 5 factorial, and so on, 2 and then say 4. So you can see here 1 factorial, then 3 factorial is 6, and 5 factorial is 120, and 7 factorial is what 5 factorial is what 5040. 5 factorial is 120 and 7 factorial is 5040. So now we are going to divide this series, each term by its factorial term. So here you can see, if we divide it by this term, if we divide by say factorial 2i minus 1 and 1 2, then sine p factorial 2i minus 1. Now if you compile, we get here say 2, and then number of terms say 4. Then you can see here it is 2 minus 1, 0.26 minus 0.025. So what is this? That is, this is what x, and that x is what 2. That is I am writing here, 1 minute. Okay, so you can, what is expansion here? We know that the series expansion is f of x is equal to x minus x cube by 3 factorial plus x5 by 5 factorial minus x raised to 7 by 7 factorial, and so on. So in place of x we put here 2. So the first term is what 2, the second term is what 2 raised to 3, that is 8, that is minus time 2 raised to 3, 8 divided by 3 factorial is what 6. The next term is what 2 raised to 5, 2 raised to 5 is what 32 divided by 5 factorial 122. The next term is what 2 raised to 7 divided by 7 factorial. So these are the 1 2 3 4 terms. So the first term is 2, next term is, you can see here we obtain here the 4 separate term. First term is 2, next term is minus 1.333, next term is 0.2667, and again alternate positive and negative sign. Now next we want to just sum up this term. So we declare here one more variable for sum. Sum is equal to 0. Now instead of here printf, we are going to write here say sum is equal to sum plus this term, and then we are going to print sum here last. The printf sum sin x is equal to say sin inside the bracket percent f is equal to percent f and x sum, bracket completed. Okay, now if you compile here, sum is 0. Now if we run here and if we take say x is 2 and number of terms say 4, then you will get the sine 2 is 0.903937. If we run one more time, say sin x is equal to say 2.1 and number of terms say 4, then you can see here sin 2.1 is what 0.861106. Now if you increase the number of terms, then you will get the your sine value is correct. But since again it is an integer, we can determine up to 4 to 7 factorial, 6 to 7 factorial, because the range of integer is 32,000. If we run one more times, and if you take here 2 and number of terms say 5, then yes, it is okay. Up to 5 it is okay. But next we cannot take the more terms. So, or in that case, if you take the you want to take a more terms, then declare here long int. Thank you.